The final section of this section, 2.6, the final content, is going to be a discussion on discontinuities, or more colloquially, holes in the graph. Before we do that, though, I feel like the last section was ended a little bit abruptly without an example. So I just want to give you one more example regarding asymptotes before we move on. And we will see some more examples in this video as well. But let's just take a look at this function here. Let's do r of x equals 2x squared plus 3x minus 9 over 3x squared minus 4x minus 4. All right, since we were just talking about horizontal asymptotes, that's where I'm going to start. So to get our horizontal asymptote, we have to compare the degrees. So notice that the degree of numerator polynomial and denominator polynomial are equal. So the degree here is 2, and the degree in the denominator is 2. It's the exponent of the largest power of x. So that tells me that the horizontal asymptote is just y equals 2 over 3. So the leading terms are 2x squared and 3x squared. And so the leading coefficients would just be 2 over 3. Now for the horizontal asymptote, we need to factor the denominator. So let's go ahead and take a look at 3x squared minus 4x minus 4. In order to factor, we have to multiply a times c. We get negative 12, add up to negative 4. And so this will actually factor to 3x plus 2, and then also x minus 2. We're now in a position to solve for our vertical asymptotes. I'm just noticing that I have a typo right there. That should say vertical. So let's set each of those factors in the denominator equal to 0. And now you've seen a complete problem in terms of solving for the horizontal and vertical asymptotes. We'll see more complete problems later on where we also do the intercepts, but again, this was just a reiteration of what we did in the previous video on asymptotes. Okay. Now, let's go ahead and get into discontinuities. All right, so let me start with an example here. Let's take a look at g of x equals x squared plus 4x minus 5 over x squared plus 8x plus 15. Now, something I haven't really discussed yet is you really should start, after you've done the horizontal asymptote at least, you really should start by factoring. And here's why. So let's go ahead and so just in general, in most problems, you're going to want to start by factoring. So let's go ahead and factor the top. It's going to be x plus 5 and x minus 1. In the denominator, we're also going to have an x plus 5, and then we'll have x plus 3. So notice these two factors actually cancel out, and this tells me that g of x just equals x minus 1 over x plus 3. So for all intents and purposes, g of x is equal to this function. However, the original function had these two factors in it, the x plus 5. So we also have to mention that x can never be negative 5. The reason for that is because g of x essentially just, it exists everywhere except right at negative 5. It's not an asymptote. It's just this spot where the graph disappears. And let me show you what I'm talking about in Desmos. So here is the graph of g of x. Notice it's x squared plus 4x minus 5, and then x squared plus 8x plus 15. If I were to graph y equals x minus 1 over x plus 3, which is what we just got, It's the exact same graph. So they literally are the exact same with one small issue. And here's what I want to point out. If I zoom in on -5, notice you can't tell that the graph stops existing. No matter how close I get, it looks fine. So we're going to do this another way. I'm going to go ahead and graph x equals -5. So here's this line that's going to move around, x equals different values. And if I click on the graph, it shows me where it intersects, right? So at -8, the y value is 1.8, and I could keep moving that, -9. So let's go to x equals -5. Notice that the graph, there's no intersection point there. Even though it looks really, really close, it looks like it should intersect. It actually doesn't, because the red graph, g of x, does not actually exist at x equals -5. It's like I took a tiny little pin and I just poked a hole in the graph right there. And that's why we sometimes call these holes as well. So in this case, we would say there's a discontinuity at x equals -5. More specifically, if we look at the graph here, it looks like the hole occurs when x is -5 and the y value is 3. But we can also check that out as well. So -5, we can show this algebraically as well. It looks like right there is where my hole happens. So if there's a discontinuity at -5, let's go ahead and just double check this. So we're going to take this function here, plug -5 in. Notice this was after I canceled out the x plus 5, because if I plug it in before that, I'll end up with 0 over 0, and that's bad, and that's no good. We don't want 0 over 0, that's undefined. So I end up with -6 over -2, which is in fact 3. And so that tells me that the hole in the graph is at -5, 3. So the graph looks exactly like this, y equals x minus 1, x plus 3. We could graph this. There's an asymptote at 1, there's an asymptote at -3, and then there's a hole at -5. So if Desmos could do this, it would look something like this, which is exactly what we saw. Okay, let's try another example just with finding the hole in the graph, and then we'll do a problem. Well, actually, we'll do the example of finding the hole, and then we'll continue the problem and find all the asymptotes and intercepts and everything. So for this next function, let's look at a of x equals, let's do x squared minus 2x minus 8 over 2x squared plus 7x plus 6. Okay, so my first step is going to be to factor. So if I factor this, I should end up with x minus 4 and x plus 2 in the numerator. And then in the denominator, I'm going to end up with 2x plus 3 and then x plus 2. So notice the x plus 2's cancel. So I end up with x minus 4 over 2x plus 3. Discontinuity when x is -2. Let's go ahead and plug -2 in. So -2 minus 4 over 2 times -2 plus 3. I end up with -6 over -4 plus 3 is -1. So in this case, the coordinates for the hole in the graph would be -2, 6. And so that's all that's required with finding the hole. I know that I sped through the factoring, so that does add to the time on a problem like this. But overall, I wanted to really emphasize the concept here and how you would find the hole and not spend a whole lot of time on factoring. So once again, once you find this value where the discontinuity is, I just plugged it back in here for x, and then this was my work for that. Okay, let's go ahead and finish up this problem. Let's go back to the original. equals, oh, I have it up here, x squared minus 2x minus 8 over okay. So to start this problem off, let's say you were told to find all intercepts and asymptotes, and you were also asked to find the coordinates of the hole, if there was one. So you start off, you say, okay, I know how to do this. The horizontal asymptote, the degrees are the same, so it's going to be 1 over 2. So the way I got this so quickly is I looked at the degrees. The numerator had an x squared. The denominator had a 2x squared. Since the degrees are the same, it was just 1 over 2. After we factored it, so next I would have factored x minus 4, x plus 2, 2x plus 3, and x plus 2. We ended up with this. So in order now to get the vertical asymptote, I'm going to set 2x plus 3 equal to 0. Notice I'm not using the hole in the graph because that wasn't an asymptote. That's a hole in the graph. So the coordinates of my vertical asymptote, the equation for it would be x equals negative 3 over 2. Please be careful with your x's and y's on these. We do need to know which one we're talking about, y equals or x equals. Next up, maybe we would solve for the x-intercepts. Now, for the rest of this problem, I'm really ignoring the hole in the graph because it doesn't apply to anything else. If I use, let's see here. If I use 2 or x plus 2 here, I'll end up with 0 over 0, which is not an x-intercept. It's undefined. So really, I just have to solve this equation for my x-intercept. You can go back to a previous video to look at that in more detail. I'm going to write it like this to avoid too much confusion. And then for the y-intercept, I'm going to plug 0 in for x, and I end up with 0 minus 4, which is negative 4/3. And so my y-intercept looks like this. And now I've gone through all the steps. Remember, to find the x-intercept, we set y equal to 0 and then solve. And then for the y-intercept, we set x equal to 0 and solve. And I just also want to point out, because I said it but I didn't write it down, I'm using this equation for the rest of the problem. So I'm essentially just saying a of x equals x minus 4 over 2x plus 3. And that's it. So for the most part, you won't necessarily have discontinuities and holes in the graph, but it is something to check for. So if you factor it, you should be able to see that. Although if you're given an equation that's not factorable, you can just check immediately, like we saw in yesterday's videos. And then you can also get the vertical asymptote, the x-intercept, and the y-intercept just by following this process. So at this point, you have all the information you need. You can now solve all the delta math, but please let me know if you have any questions about anything I've talked about. If something doesn't make sense, if I went too quickly or too slowly in parts, please let me know, and I will